Our today's lesson starts with inverse of a determinant. If definition, if A and B be two determinants such that A into B is equal to B into A is equal to I. I means identity determinant of the order of A and B. If A and B are of second order, then it is I2. If A and B are third order, this is I3. Then A is inverse of B and B is inverse of. So they are inverse to each other. Now note that let A is a determinant. This is a third order determinant. We'll go with third order. Now we know that adjoint A is the determinant. These two determinants is well known to us. This actually. Now if we multiply A by adjoint A, what will be the multiplication? A. Now see, if I on multiplying this row method, first row into first row, what we say A11 C11 plus A12 C12 plus A13 C13. This is nothing but A, value of A. Look, the first row elements are multiplied by first row cofactors. So the first element is A. Now are these two elements. First row elements are multiplied by second row cofactors. So that is 0. First row elements multiplied by third row cofactor. Again 0. Second row element multiplied by first row cofactor. 0. Second row element multiplied by second row cofactor. A. 0. 0. 0. Now say from the result we get A into adjoint A is A to the power n in, where n is order of A. So A to the power n, on dividing both sides by A to the power n, we arrived at A into adjoint A by A to the power n is equal to in. Now from definition of inverse, this is inverse of A. So A inverse is equal to adjoint A by A to the power n. Now question arises, when A is 0, that is determinant, the value of the determinant is 0. Obviously, when A is 0, this is undefined. So when the value of a determinant is 0, then its inverse does not exist. To have an inverse, the value of the determinant must be non-zero. And when value of a determinant is 0, the determinant is called singular determinant. So to have an inverse, the determinant must be non-singular. That is, its value is non-zero. Only the determinants whose values are non-zero, they have the inverse. And inverse of a determinant is adjoint A by A to the power n. That is, A to the power n means all elements of adjoint A are divided by A. All elements equal to nothing but C11 by A. Is inverse of A. A is equal to 2, 5, minus 3, 10, 7, minus 6, 8, 0, 3. The plus. What is adjoint A? This element. Eliminate these two. So 7 into 3, this is 3. 7 into 21 minus 0, that is 21. 21. And it is first element, so it is sign rule plus minus plus minus plus minus plus minus plus. This is sign rule. So plus means that you should retain the sign. 21 arrived, so you will keep 21. For 5, 5 2, so 30 plus 48, so 78. 78, its sign is minus, so minus 78. Now see, for 3, that is 0, minus 56, minus 56, its sign is plus, so keep the sign. Now for 10, it is 15 minus 0, so it is 15. It is minus element, so change the sign. For 7, it is 6, plus 24, that is 30. It is plus element, so retain the sign. Then for 6, minus 6, eliminate this 0 minus 40. So minus 40. It is minus element, so make it plus. 8 minus 30 plus 21, that is minus 9. Minus 30 plus 9, minus 9 plus element, so retain the sign. For 0, it is minus 12 plus 30, that is 18. It is minus, so it is minus, change the sign. Then for the last element, 14 minus 15 minus 36 is 18. This is at how to find the value of A. We know all the cofactors. So choose any row or any column and multiply it by the corresponding cofactor. I will choose this third row because 1 0 is there. So 8 into 9 minus 72. This is 0. This is 3 into 36 minus 108. So it is minus 180. So det A is 180. So A inverse is 1 by minus 180 to the power 3, since it is third order, into adjoint. Next, just a definition. Orthogonal determinant. Orthogonal determinant. What is orthogonal determinant? If A transpose is equal to A inverse, then A is orthogonal. Just sometimes question arise, you are asked to prove that a given determinant A is orthogonal. So you have to take its transpose and to show that A transpose is inverse of A. So question arise like this. Prove that A is equal to HGBG is orthogonal. Orthogonal. Then we have to proceed like this. Answer A is equal to this. Hence A transpose is equal to, after taking transpose, then A into A transpose is equal to, take the product, take the product and show that this product is 100,010,001. If A is orthogonal, this product will this. If not, it will be anything else. So that implies A transpose is equal to A inverse, implies A is orthogonal. These simple sums, only the term, meaning of the term matters. Now question is, prove that value of a skew symmetric determinant of odd order is 0. Now I am going to prove that. Answer. Let Aijn be a skew A is equal to skew symmetric determinant of odd order. Hence, n is odd. N is odd. Now, we know that A is equal to A transpose. Value of a determinant remains unchanged when transpose is taken. Hence, A transpose, now see A transpose is, so when we are taking transpose, row become column and column become row. So Aij become Aji. So the determinant was Aij, now it becomes Aji. That is, it will be of the form A11, A21, A31, AN1, A12, A22, A32, AN2, AN1N, A2N, A3N, ANN. Clear? The previously this was the first row, second row, third row, now they become column. Now we take -1 common from each of the row. -1 common from each of the row. So there are n rows, so we get -1 to the power n. The elements become -A11, -A21, -A31, -A12, -A22, -A1n, -A2n, Taking -1 common from each row, the determinant reduced to this. Now, since this determinant is skew symmetric determinant of odd order, so -Aij is Aji. -Aij is Aji. So that equal to, since n is odd, it is -1 into, now A11 become -A11 becomes plus A11. Here I or J's are interchange, the sign interchange. Aij is equal to -Aji. So -A21 become A12. -A31 becomes A31, A12 minus A12 becomes A21, A22, A1n becomes AN1, AN, . Now see, it is minus A. Now see, this is nothing but minus A. Minus A, because this is A. And adjoint A transpose is equal to this. And A transpose is A. So that gives you, hence A is equal to minus A, or 2A is equal to 0. or A equal to 0. So minus A31 is A13. So when these two are interchanged, the sign changes. In HS exam, you can show this proof taking a third order determinant like this. A is equal to, now we know that the diagonal elements become 0. We have already proved. So this is A, B, this is C. Since it is A, it is minus A. Since it is B, it is minus B and a minus. Take a determinant, skew-symmetric determinant of like this. So A is this. Now you can prove that value of A is 0. That will prove the theorem for third order only. But HS syllabus is limited up to third order. So that is equal to, now I am taking transpose. So first column becomes first row, minus A minus B. Second column becomes second row, minus C. Third column becomes third row. Bracketed, right? Taking transpose. Taking transpose. Taking transpose. Now take minus 1 common from each of the row. That is 0AB. Minus 1 is divided with this. So minus A, 0C, minus divide, minus B, minus CC. What we have to do, that I have to write. That is, I multiplied R1 dash, that is new R1. R1 dash represents new first row, is minus 1 into R1. So first row is multiplied by minus 1. That since it is multiplied by minus 1, it is divided by minus 1. So it is minus 1 to the power 3. For this, minus 1, for this, minus 1, for this, another minus 1. So 3 minus 1, there minus 1. R2 dash is equal to minus 1 into R2. And R3 dash is equal to minus 1 into R3. That this way we can write what we have done. So that is equal to minus 1, and note that this is it. Hence 2A is equal to 0 or A is equal to 0. So now see, the proof of the theorem becomes more easy. Cramer's rules is the method of solving simultaneous linear equation. This method I will teach you by some example. Taking some example. Example 1. Two variables. Example 2 will be of 3 variables, and you can solve for n variables also. The method is just you have to extend the method. 2 variables. Question will be solve 5x minus 7y is equal to 3. 2x plus y is equal to 5. This kind of problems you solve in class 9. You solve this by three different methods. First, elimination. Second, cross multiplication. And third, graph. And in elimination, you follow three different ways of eliminating. First, by equating coefficients, that is popularly known as elimination. Second, by method of comparison. And third is method of substitution. All are elimination and only different process of elimination. Now we are going to learn the fourth method, that is method of determinant. Step 1, express all equations in the form x plus by equal to c. X plus by equal to c. And my equations are already in this form. In exam, you may got the equation in this form. So from there, you have to convert this equation in this form. That is, after that, you have to write it in this form. This is equal to 3. Step 2. Construct three determinants. Three determinants you have to construct. First determinant is denoted by delta. 5 minus 7, 2, 1. This is called coefficient determinant. This is called coefficient determinant. That is, coefficient of x forms the first column, coefficient of y forms the second column. That's why it is important to write x in below x, y in below y. So don't miss up this. This is called coefficient determinant. Second determinant is sometimes called by delta x or delta 1. In this delta x, the coefficient of x, that is 5 and 2, are replaced by constants. That is 5 and 2 replaced by 3 and 5, and all other elements remains unchanged. In this, coefficient of x are replaced by constants. Constant, that is 3 and 5. Likewise, delta y, in this, the coefficient of y's will be replaced. From here, not from here. From here, coefficient of y. So 7 and 1. So 5 and 2 will remain unchanged. Minus 7 and 1 will be replaced by 3 and 5. That is, that you can write. Step 4. Calculate the values of the determinants. Calculate the values of the determinant. For example, value of this determinant is 5 plus 14, 19. Value of this determinant is 3 plus 35, that is 38. Value of this 25 minus 6 is equal to 90. So calculate the value. I have completed step 4. Step 5. X is equal to delta x by delta. Y is equal to delta y by delta. So delta x is 38 by 19 is equal to 2. That is 19 by 19 is equal to 1. Now see, 2, 1 is the solution. Say 2, 1 satisfies both the equations. delta, three variables. You have to solve this. Now see, this equation is not in the form equal to constant. So there is a free constant on the left hand side. First you have to rewrite the equations. 5x minus 6y plus 2z is equal to minus 17. 4x plus y minus 6z is equal to 90. X plus 7y minus 3z is equal to 20. Now see, from here delta is coefficient determinant. Coefficient determinant is formed by making columns using the coefficients. Minus 6, 1, 7. 2 minus 6 minus 3. Only coefficient, no variable. Now you can find out its value. 5 into, I expand it with respect to first row. 5 into minus 3 plus 42, that is 39. Minus 3 plus 42. 42 minus 3, 39. Plus 6, minus 6, but it is negative element, so you have to change to one element, so you have to change its sign. 6, that is minus 12 plus 6 plus 2, it is 28 minus 1. So it is 195 probably. This is 6 minus 36. This is 54. So you can calculate this value. Next, delta x. Delta x is obtained by eliminating coefficient of x by this constant. So minus 17, 19, 28 and 6, 1, 7, 2 minus 6 minus 3. Now you can calculate its values. Similarly, delta y is obtained by eliminating coefficient of y from delta, keeping all other coefficients same. 5, 4, 1 and 2 minus 6, 3 minus 3 remains unaltered. Only minus 6, 1, 7 replaced by minus 17, 19 and 20. And its value you can calculate. Similarly, delta z you can calculate. That is, in this case, we will replace coefficient of z, that is 2 minus 6, 3, keeping all other remains unchanged. So 5, 4, 1, minus 6, 1, 7, and 2 minus 6, 3 replaced by minus 17, 19, and 20. Now you can calculate its value. After calculating, your x will be delta x by delta is equal to, calculate y is equal to delta y by delta is equal to, calculate z is equal to delta z by. This is the method of finding solution of simultaneous linear equation of multiple variables. Now see, x is equal to delta x by delta. Y is equal to delta y by delta. and z is equal to delta z by delta. Then what will happen when delta is equal to 0? Then what will happen? If delta is equal to 0, the conclusion depends on delta x, delta y, and delta z. When delta is equal to delta x is equal to delta y is equal to delta z, all 0. When all of these become 0, then the equations has infinite solution. Infinite solutions. You just recall your memory. Class 9. You learned about ax plus by plus c equal to 0. Px plus qy plus r equal to 0 has infinite solutions. When a by p is equal to b by q is equal to c by r. This was the condition of having infinite solution. Now see, if this happens, what will be delta? Delta is a, b, p, q. Now see, it is aq minus bp. Now see, aq minus bp is 0. Because aq is bp. Delta x. Delta x is c r bq. So that is cq minus br. Now see, cq is br. So this is also 0. Now see, delta y. Delta y is APCR. APCR, that is AR minus BC. See, AR is equal to PC. AR is equal to PC. So this is also 0. So in class 9, we learned everything about it. When all are 0, delta 0, delta x 0, delta y 0, then it has infinite number of solutions. But if delta is 0 and at least one of delta y, delta x, delta y, and delta z is non-zero, then it has no solution. So this equation has infinite solution. But if delta is equal to 0 and delta x square plus delta y square plus delta z square not is equal to 0. When it happens, all are positive. Sum is non-zero. That means at least one is non-zero. So that, in other words, that is at least one of delta x, delta y, delta z not is equal to 0. Then the system of equation has no solution. The system of equation has no solution. Clear? And when delta not equal to 0, it has an unique solution. It has an unique solution when delta not equals to 0. That we have learned in class 9 also. Since A by P not is equal to B by Q, that implies unique solution. A by P not is equal to B by Q implies determinant AP BQ not is equal to 0. That was the condition of unique solution we learned in class 9.